122 is divisibility rules. Given a number, how do you tell if it's divisible by 1? Given a number, how do you tell if it's divisible by 2 or divisible by 3? So the rule for 1 is every number is divisible by 1. When I say number, I mean whole number. I probably won't keep stating whole number, but I mean whole number. Every whole number is divisible by 1. What does divisible mean? Well, 8 is divisible by 2 because you get a whole number. A is divisible by B if you get an integer. If that's an integer, C is an integer. It's not a mixed number. And you can divide 8 by 3. You get 2 and 2/3. But you can't say 8 is divisible by 3. And the question is, how do you know a number is divisible by 2? How can you just look at 8 and say, yep, it's divisible by 2? How can you look at 8 and say, no, it's not divisible by 3? How can you take 125 and say, no, it's not divisible by 3? What is the rule to know if a number is divisible by 3? That is, if 3 goes into a number. And that's what we're going to talk about now. How do you tell if a number is divisible by 3? Well, it just is. Every number is divisible by 1. I may have said 3. I meant to say 1. How do you tell if a number is divisible by 1? You just say, yes, it is. Every number is divisible by 2. How do you know if a number is divisible by 2? Well, you look to see if it's odd or even. That is, if the number ends in a 0 or 2 or 4 or 6 or an 8, that is, if it's an even number, then it's divisible by 2. 2 goes into every number evenly. 2 goes into every number that ends in 0, 2, 4, 6, or 8 evenly. And it won't go into any other number. It doesn't end in 0, 2, 4, 6, or 8. Okay, 3. The test for divisibility by 3. You add up the digits of the number. If 3 goes into this sum, then 3 goes into the number. If 3 does not go into the sum of the digits, then 3 does not go into the number. Okay, what on earth is all this saying? Let's look at concrete examples. Does 3 go into this number? Does 3 go into this number? Well, I don't know. One way of doing it is to try it. Just do 3 into the number. Another way is to add up the digits. 1 plus 2 is 3, plus 7 is 10, plus 3 is 12. Does 3 go into this number? The answer is yes. 3 does go into 12, 4 times. That means 3 goes into the original number. 3 goes into that number. You add up the digits. That's the game. If 3 goes into the sum of the digits, then 3 goes into the number. 171412. Add up the digits. 8 plus 1 is 9, plus 4 is 13, plus 1 is 14, plus 2 is 16. 3 does not go into 16. So 3 does not go into 17, 14, 12. You don't even have to test. You don't have to do 3 into this number. Just add up the digits. That is the test for 3. Add up the digits, and if 3 goes into the sum, you want to know if 3 goes into a number. Take that number, add up the digits. If 3 goes into the sum of the digits, then 3 goes into the number. If 3 does not go into the sum of the digits, then 3 does not go into the number. The rule for 4 is a little bit easier. A number is divisible by 4 if 4 goes into the last 2 digits. Now, when I say go into, I mean even. So, if I give you this ridiculously long number, and somebody is asking you, they're not saying how many times does 4 go into this number. Just does 4 go into this number? Does 4 go into that number? Well, you can do the long division if you want. You can do 4 into that long, long number. Or you can look at the last 2 digits. Since 4 does go into 36. 4 times 9 is 36. 4 goes into 36 9 times. Since 4 does go into 36, we conclude that 4 goes into that original number, 1, 2, 4, 5, 4, 8, and so on, up to 3, 4, 3, 6. 4 goes into this number. If you want to write down the whole number, write it down. I won't. 4 goes into that number. Just look at the last 2 digits. If 4 goes into the last 2 digits, then 4 goes into the number. If 4 goes into the last 2 digits, then 4 goes into the number. If 4 does not go into the last 2 digits, then 4 does not go into the number. And 4 does not go into the number. It's a very straightforward test. Here you didn't even have to add the digits. If 4 does not go into the last 2 digits, then 4 does not go into the number. Five goes into a number. 5 goes into a number only if that number ends in a 5 or 0. And again, when I say a number, I mean the whole number, not a fraction, not a decimal number. 5 goes into a number only if the number ends in 5 or 0. Does 5 go into this number? The answer is no. Because the last digit is not a 5 or a 0. Does 5 go into this number? Answer is yes, because the last digit is a 0 or a 5. This has to be one of those digits, and it is. It's a 0. So 5 goes into that number. For the next one, I want 2 and 3 to remain on the board. A number is divisible by 6 if it's divisible by 2 and 3. That is, if it follows the rules for 2 and 3. It ends in an even digit, and when we add up the digits, 3 goes into that number. A number is divisible by 6 only if it is divisible by 2 and 3. That is, it satisfies the rules for 2 and 3 above. If it satisfies the divisibility rules, assuming that was clear. Divisibility rules for 2 and 3. So for example, 3, 2, 1, 4, 2, 0, 3. This will not be divisible by 6 because it's not an even number. 3, 1, 4, 0, 5, 1, 2, 8, 4. This is an even number that will satisfy the divisibility rule for 2. So now is it divisible by 3? We add up the digits. 3 and 1 is 4, plus 4 more is 8, plus 0 is 8, plus 1 is 9, 11, 19, 23. The answer is no. 23, I think we got. 8, 6, 23. If I add 1 more, that's 24. This number, it is an even number. That is, it has to satisfy rule 2 and 3. It satisfies rule 2, it's an even number, and the digits add up to a number that 3 goes into. So it satisfies the divisibility rule for 3. 2 and 3. The answer is yes. So the first number, it failed 2. I don't care about whether it passed 3 or not. Doesn't matter, it failed 2. That's to pass both a test. Test for divisibility by 2 and the divisibility test for 3. Okay. Now, for number 7, it is a divisibility test for 7. But that's just for completeness. It is not an easy test. There's not even a point for us to state it at this point. For us, the divisibility test for 7 is to try long division. That is, the 7 is 105 divisible by 7. I don't know, let's see. 7 into 10 is 1 time, 3 left over. 7 into 35 goes evenly. The answer is yes. 105 is divisible by 7. Is 1, 2, 1, 3, 1, 4 divisible by 7? I have no idea. The easiest way of doing it is to actually try it. 7 into 12 is 1 time with 5 left over. 7 times 7 is 49. From 51, that leaves 2. 7 times 3 is 21. From 23 leaves 2. Oh, okay. 7 into 21 is 3. Remainder 0. 7 into 4. It goes 0 times, but there's a remainder. So no, this number is not divisible by 7. That's the easiest way of doing that. Okay. The divisibility test for 8 is check to see if 8 goes into the last 3 digits. If it does, then 8 goes into the number. If it does not, then 8 does not go into the number. For example, 1, 2, 3, 1, 4, 8, 2, 1, 3, 7, 8, 8, 9, 6. Does 8 go into this number? Now, you can do the long division. Nobody's asking you how many times 8 goes into that number. Does 8 go into that number? You can do long division. Or you can just see if 8 goes into the last 3 numbers. 8 goes into 8 one time, nothing left over. 8 goes into 9 one time, 1 left over. 8 goes into 16 2 times, nothing left over. Yes, 8 goes into this number. Just check the last 3 digits. Just check the last 3 digits. Nine. Very similar to 3. Add up the digits. If 9 does go into this sum, then 9 does go into the number. If 9 does not go into this sum, then 9 does not go into the number. 1, 2, 3, 4, 5, 3, 2, 1, 4, 8, 9, 2, 3, 7, 2. Does 9 go into that number? Add them up. 1, 3, 6, 10, 15, 18, 20, 21, 25, 33, 42, 44, 47, 54, 56. 9 does not go into 56. 9 times 6 is 54. Below 56, 9 times 7 is too much. The answer is no. Add up the digits. I'd rather add up those many numbers than do long division. Long division can be brutal. Just add up, in this case, 4, 5, 8, 10, 15 numbers. Add up 15 numbers. You don't want to do long division with a 15-digit number. And that's the divisibility rule for the number 9. Okay, the next one we all know, but let's write it down formally. Divisibility test for 10. Only if the number ends in a 0. If it ends in anything but a 0, it's not divisible by 10. Now, why might you need this? Well, you have big numbers and you want to reduce them. If somebody gives me 126 divided by 18 and I'm asked to reduce this, well, I don't know. I feel like adding the digits. When I add the digits, I get numbers that 9 goes into. 9 goes into 9 and 9. The top digits add up to 9. The bottom digits add up to 9. So 9 goes into both of those numbers. Let me say it more clearly. I add up the top digits, I get 9, and 9 goes into that number. 9 goes into the sum. So 9 goes into the number. Now you should know 9 goes into 18. But if you add the 1 and 8, you get 9. And since 9 goes into that sum, 9 goes into the number. So I'll bother to divide the top number by 9 and see what I get. I get 14. Okay, 9 goes into the top number 14 times. 9 goes into the bottom number 2 times. And you should know that 2 times 7 is 14. That is 14 divided by 2 is 7. Problem's done. If somebody asked you, what is 1341 divided by 27? I'd add up the digits. I love those 2 rules. I add up the digits. I'm going to change the problem. 8. Yeah, let's just put another 9 here. When I add up the digits on top, I get 18. 9 goes into 18. So 9 goes into that number. And 9 goes into 27. So I'm going to divide the top and bottom by 9. 9 goes into 9 one time. Nothing left over. 9 goes into 1 0 times with 1 left over. 9 goes into 13 one time with 4 left over. 9 goes into 44 4 times with 8 left over. 9 goes into 81 9 times. I get 10149. When I divide the top number by 9 and the bottom number by 9, I get 3. Now the only number that goes into 3 is 3. Does 3 go into the top number? I don't know. Add up the digits. They happen to be right here. 1 plus 0 is 1, plus 1 is 2, plus 4 is 6, plus 9 is 15. 3 goes into 15. That means 3 goes into this number. 3 times 3 is 9, 1 left over. 3 times 3 is 9, from 11 is 2 left over. 3 into 24 goes 8 times evenly, and 3 into 9 goes 3 times. So I divide this number by 3, I get 3383. Divide the bottom number by 3, I get 1. The answer is 3383. Okay, these are big numbers. Coincidentally, it turned out to be a fraction. If I would have had 50, it didn't turn out to be a fraction. If I had 54 instead, well, these digits add up to 9, so 9 goes into 54 6 times. 6 times. And I know 3 goes into 6. And I just learned 3 goes into 10,149 by adding up the digits. Divide the top number by 3, get this. Divide the bottom number by 3, get that. Flip over 2. Why did I change it? I don't want you to say, this guy's crazy. Why don't I just do 5, 4, 2, 7 into? And the answer is, it may not go evenly. It may not go evenly. Okay, here's a good start on how to reduce fractions yet again. You need to know your divisibility rules. They're definitely good rules to know. That way when you're up against big numbers, 1, 2, 4, 1, 4, 9, 6, divided by 1, 3, 2, 1, 4, 48. You should say, you know what? 4 goes into both of these numbers, because 4 goes into the last 2 digits. That's very helpful. Probably do the long division. At least when I do my long division, I know I'm not going to be sorry that I bothered doing it. I'd be sorry if 4 didn't go in there. Okay, 3 times into 12 into 4, 1. 4 goes into 1 0 times. That's now 14. 4 times 3 is 12. That leaves 2 left over. 4 times 7 is 28. That leaves 1 left over. 4 goes right into 16. I knew it. I would have bet my life that 4 went into that number. Because 4 goes into 96. And 4 also goes into 48. So 4 is going to go into any number. It ends in 48. 3 times, that's 12. From 13 is 1 left over. 4 into 12 is 3, evenly. 4 into 4, 1. 4 into 4, 1. 4 into 8, 2. So, I made some accomplishment. Now, both of these numbers are still even. They're still even. That meant 8 went into both of them. If you divide by 4 and then you divide by 2, that's the same as dividing by 8. 4 times 2 is 8. Turns out that 8 goes into this number, and 8 goes into this number. The test for 8 is the last 3 digits. So let's try 6. Add the digits. 3, 4, 7, 14, 18. 3 goes into the top number, and 2 goes into the top number. That means 6 does. 3, 6, 7, 8, 10. 3 does not go into the bottom number. So 6 will not. But 2 will. Top number divided by 2 to save a little time is 155, 182. Now, the bottom number is 16. Oh, why am I having trouble with this? 1, 6, 5, 5, 6. It ends in a 7, sorry. Okay, so we have this. Now, I can't divide by 2 because the top number is not divisible by 2. 3. 7, 17, 23. It's not divisible by 3. The top number is not even, so 4 is no good, 5 is no good, 6 is no good for top and bottom. No odd, no even number. So we'll just try odd ones. 7, 9, 11. Well, 9's not going to work because the bottom number added up to 23, which is not the multiple of 9. 9 did not go into some. Maybe 9 goes into the top number, but I want a number that goes into both the top and the bottom. 7. For 7, you just have to get your hands dirty. The odds that both of those numbers are divisible by 7, and I didn't rig that, is probably 0. Seven does not go into 67, so 7 doesn't go into the top number. 9 does not. You can try 11 and 13. Don't try 15. Every number on the 15 table, ends in either a 5 or a 0. A 5 or a 0. Not every number that ends in a 5 or a 0 is on the 15 table. 25 is not on the 15 table. Okay, so you might try 17 and 19. It's very possible that those two numbers over here, these two numbers are prime. Well, they're not prime. They can be what's called relatively prime. Nothing goes into both of them except 1. It's not relatively, then the bottom number is not prime. 2 certainly goes into it. So what you can do now is try prime factorization. I'd rather do prime factorization on a 5-digit number than a 7-digit number. Alright, so here are ways to use the test to reduce. Okay, that completes the section, and good luck with it.